This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome back to Chapter 3 of our series, Building Your First Autonomous Agent. In this episode, titled Design Principles for Autonomous Agents, we'll explore essential design principles that will help you create robust and reliable agents. So, whether you're just starting out or looking to refine your skills, let's dive in. A car glides through city streets with no one touching the wheel, yet somewhere, a human still quietly sets its boundaries. Here's the paradox. The more autonomous our agents become, the more invisible human decisions shape every move they make. That quiet layer of human influence isn't just philosophical, it's baked into every design decision. Which data the agent sees, which goals it pursues, which failures are acceptable, and which are catastrophic. Before you write a line of code, you're already choosing what success means. A delivery drone tuned for speed will evolve very differently from one tuned for reliability, even if they share the same hardware and algorithms. One will squeeze through tight gaps and cut corners, the other will reroute at the slightest uncertainty. These trade-offs become even sharper as agents scale from a lab prototype to a fleet in the wild, exposed to messy environments, strange edge cases, and creative users. In this series, we'll treat those trade-offs as design materials, things you can shape deliberately, not just side effects you discover too late. Those early choices quietly determine your agent's shape long before it moves in the real world. A Mars rover creeping across unknown terrain, Waymo's cars sharing lanes with impatient humans, even AlphaGo exploring impossible-looking go lines, they all reveal the same pattern. Robust agents are engineered to survive surprise. But robustness alone isn't enough. You also need systems that scale from one prototype to thousands of deployments, and that stay aligned with human values as they learn. This series will keep circling three pillars: robustness, scalability, and ethics, as practical design constraints, not vague ideals. Think of this episode as zooming one level deeper. Not, should we build an agent, but what are its organs and how do they cooperate under pressure? Most modern agents, from NASA's Perseverance rover to a Waymo car, orbit around a repeating loop. Sense, decide, act, learn. The details vary wildly, but the architectural questions rhyme. What does the agent notice? How does it turn that into choices? How does it update after those choices go wrong? Perseverance's AutoNav has a constrained, high-stakes loop. It builds 3D terrain models, predicts where it might slip or crash, then commits to short hops of motion, just enough to be safe on unknown ground, but long enough to cover 200 meters in a day. Meanwhile, the communication delay to Earth forces a design where ask a human every time simply isn't an option. Robustness is not an add-on, it is the control strategy. Waymo's 0.00037 disengagements per 1,000 miles tell a scalability story. You don't hit that number by handcrafting every behavior. You engineer modules, perception, prediction, planning, so they can be improved, swapped, or retrained independently. Safety review tools, simulation pipelines, and data curation systems are just as important as neural networks. The more vehicles you deploy, the more your bottleneck shifts from, can the car see pedestrians? To, can our organization absorb and act on millions of edge case miles each day? On the learning side, AlphaGo showed how combining brute force search with learned intuition changes what good design looks like. Instead of exploring the full game tree, it evaluates 100,000 positions per second, but steers that computation with policy and value networks that prune hopeless branches. The lesson: structure your agent so it spends its effort where it matters, not just where it's easy. As language models turn into generalist agents, that loop adds another layer: human feedback. A pipeline like RLHF, with thousands of labelers influencing reward models, embeds a kind of crowdsourced governance. The agent's preferences are no longer just loss functions. They're negotiated artifacts of human judgments, incentives, and blind spots. Your challenge this week? Pick a real system. Perseverance, Waymo, AlphaGo, or an LLM assistant, and sketch its sense, decide, act, learn loop in 4 boxes. For each box, write one way it could fail dangerously at scale. Don't fix anything yet. Just surface where robustness, scalability, and ethics will collide once your first prototype actually meets the world. Think less about a smart agent and more about a small ecosystem you're cultivating. A home robot that tidies your living room, for instance, needs different design choices in a studio apartment versus a family home with pets and toys everywhere. In the studio, tight navigation and compact storage matter most. In the family home, the real challenge is ambiguity. Is that blanket clutter or part of someone's bed? The same sensing hardware can lead to wildly different behaviors depending on how you structure its internal priorities and fallback rules. This is where the 3 pillars start to pull against each other in concrete ways. A hyper-robust cleaning policy might refuse to move anything it can't perfectly classify. Very safe, but nearly useless. An aggressively scalable design might share one universal model across millions of homes, but then struggle with niche layouts or cultural norms about what's okay to move. And ethics surfaces in the small details. Should the robot read labels on pill bottles if that helps it avoid dangerous chemicals? Or is that too invasive for a domestic helper? Future agents won't just follow rules, they'll negotiate them in real time. As they coordinate with legacy software, human teammates, and other agents, misaligned incentives will surface in subtle ways, like a sales bot overpromising to hit a target while a billing bot quietly blocks risky deals. Your real design power shifts from picking single objectives to shaping the relationships between many partial, sometimes conflicting goals. Sooner than you think, your first agent will start surprising you, not by going rogue, but by revealing gaps you didn't know were in your own thinking. Treat those surprises as signals, like stress tests on a new bridge. Each weird edge case points to where your next design principle should harden, flex, or deliberately stay open-ended. Here's your challenge this week. Design and deploy a single autonomous agent that runs end-to-end without you touching it for 24 hours. Pick one concrete workflow, for example, summarize the top 5 AI papers from Archive Daily and email me a 200-word brief, and explicitly encode at least 3 design principles from the episode. 1. Clear objective plus success metric. 2. Constrained action space. And 3. A feedback loop. For example, it logs decisions and auto-adjusts based on your rating of yesterday's summary. Ship it today in its simplest functional form, no refactors, no extra features, and tomorrow, review its logs and outputs, grading it against the principles from the episode. This was OwlUp, your daily step forward. This series continues with more chapters on OwlUp.co. Visit OwlUp.co to access the complete course and continue your learning journey. See you there!